Hey everybody, Wasseem checking in. This is going to be a video talking about Euler's formula and how we can apply it to some pre-calculus questions. So let's just get started. So, what is Euler's formula? So Euler's formula, Euler, you might know Euler from the number E equals 2.718, etc., right? So you guys might know him from that number, and he came up with this little formula sorry about that. That's gonna It's going to help us with a lot of these problems on pre-calculus. So Euler's formula has like two variations in which the sign is changed in one of them. So the standard form is e to the I times theta power is equal to cosine of theta plus I times sine of theta. And then the other form of it, in which you negate this exponent and causes you to negate this as well, is going to be e to the negative I times theta power is equal to cosine theta minus I times sine theta. So it's really important to be able to differentiate the two. If you ever see the I negated, then you're going to have to make the plus a minus as well. So now that we know what Euler's formula is, let's try to see if we can solve these problems. So we have cosine of I minus I times sine of I is the equivalent to what? Well, first we have to recognize which one of Euler's formulas this is. Well, and obviously the best way to know is because of the minus right there. So, and we also need to understand now that cosine of I, that's inferring that I is going to be our theta. So, now that we know our theta and we know which one of these formulas to use, let's see how we can simplify it. Let's rewrite it with theta first. So we have e to the negative I because of the minus times our theta, which is just I. And for our purposes, let's actually just rewrite this into negative I squared, right? And then that's going to be equal to this guy, cosine of theta. Remember, our theta is going to be I. So cosine of I minus I times sine of I, right? And we don't want to change anything on the right because we kind of can't. And also, we already have the right side equal to what we want. So let's worry about this left side. So we have e to the power of negative I squared. So let's worry about this guy. So we have e. So hopefully all you know that I squared is going to be just negative 1. So because it's rad negative 1 squared. Cancels out the rad sign. So we're going to have just negative 1. So we're going to have negative times negative 1, which hopefully you just realize is obviously just going to be 1. So e to the 1, which is just e, is going to be equal to our expression cosine of I minus I times sine of I. So there's our answer, e. This next question is a little more tough because two things. You have to recognize that it's Euler's formula, which can be harder than it looks sometimes, and you also have to know how to simplify matrices. So we have this, and we should be able to understand that we're going to be using Euler's formula because, I mean, if you look in the answers, that's our general form. Like that's what it equals right there. So you know that this has something to do with Euler's formula. Now let's worry about simplifying this matrix. So we have this 2 by 2 times a 1 by 2 or a 2 by 1, I can never tell. And the way I choose to remember this and how to simplify it, well, you're going to end up with this same kind of matrix. And I just remember it as the top number gets multiplied by everything on the left, and the bottom number gets multiplied by everything on the right, and then you rewrite it as like the smaller one. So let's apply that. So let's start with this 3 times everything on the left. So we're gonna have 3 times cosine theta, and then below that it'll be 3 times 1/3 of 1/3 I cosine, which will just end up being 1. So we have I cosine theta. And then let's do the sine theta times 1 is just going to be sine theta. So we add that to our previous guy. So plus sine theta. And then sine of theta times 3i is just going to be 3i. So plus 3i times sine of theta. So now that we have this guy, hopefully you all realize that, yeah, this looks just like our Euler's formula, but we're going to have to simplify it a little bit more. So what can we do with this top guy? We have 3 cosine theta plus 3i sine theta. If we want that top expression to look like the one that we already know, we're going to have to factor out that 3. So let's change that to 3 times cosine theta plus or minus plus I sine theta, right? And now look what we have in the parentheses, cosine theta plus I sine of theta. Can we not just rewrite that as this guy? Spoiler alert, we can. So let's erase this and change it to simply e to the I times theta, right? So already with this top guy, you can already narrow it down to a 50-50, but we want to figure out the entire question. So how can we simplify this bottom one? The bottom one is a little tricky. So think about it. We have I cosine theta plus sine theta. The i's are swapped. So where should you start with this? Well, you need it so that I is on the sine of theta. So what I did, and what I think it might be the best strategy, is just factor out the I for now, I of cosine theta, and then put I sine theta because that's what we want, right? And then worry about how we can what if we put a minus here, can we distribute the I and have it turn into a plus? That's kind of what we want to figure out. Because whatever if we put plus or minus here, we need to remember that it has to when we distribute, it has to equal this guy. So, spoiler alert, it's going to be minus because think about it. If you distribute the I to the other I, you get I squared, which is -1, and then you have this minus -1, which just becomes a plus. So we end up getting this expression anyway. So after factoring that one out, you get, yeah, I cosine theta minus I sine of theta. So you're going to have I times cosine theta minus I times sine of theta. So but let's look at what we have in parentheses because it might be familiar to us. Cosine of theta minus I sine of theta. Again, I'll remind you guys, please remember to look at the minus or to see if it's a minus or a plus, so then you know which formula to use. In this case, it's a minus, so we can use this guy where the exponent is negated. So we'll have so we can simplify everything in the parentheses to just e to the negative I theta. And that's our entire matrix. And it should hold up. That should be 3 positive and negative. It should be this guy right here.